So, hey everyone, I'm starting the session now. So, the session is all about machine learning roadmap. So, what you need to know and what you need to learn proceeding with the machine learning session, and all the necessary part that you need to know while learning the machine learning will be introduced in this session. So let us proceed forward. And the table of content for today's session is a speaker introduction, that is mine only. What is machine learning? The third part, I'll be discussing about machine learning roadmap, and the last is your stage, that is Q&A session. So, starting with the machine learning, what is actually machine learning? So, machine learning is a branch of artificial intelligence and computer science, which mainly focus on the use of data and its algorithm to imitate the way that humans learn and gradually improves its accuracy. So, what happens in machine learning? We actually fed the data in the machine, and the machine basically learns what our data is saying, and at the output, it uh, for the output of that machine, it gives us the accuracy and the model building. So we fed the data in the machine execute process the data and give the outcome as what a model what will be the outcome of a model. So machine learning is an important component of the growing field in data science. Like we have data science, we have AI, NLP, machine learning, and statistics. These are the four major core part of the data science, and machine learning is a subset of data science. So through machine learning, the use of statistical methods, algorithms are trained to make classification or prediction and to uncover key insight in data mining projects. So what is the use of machine learning? So we basically train a model, fed our data, and classify and predict the outcome, and find the insight of that particular model, what the model is saying. So we find the insight of the projects. These insights subsequently drive decision making within application and businesses, ideally impacting key growth matrices. Now you might be knowing about big data. So these days the big data technology is evolving, and the use of machine learning plays a very important role in big data. So as the data grows, the big data demand is more and more in the current market. So big data continues to expand and grow. The market demand for data scientists will increase, like I said. So so here you will know about the human and the machine interaction. So this is a small picture that depicts about human and machine. So human is saying, I can learn everything automatically from experience. Can you learn? So it's asking the machine, can you learn what I can do? So machine is saying that I can learn from the past data. So machine learning is basically all about learning from the data we fed into the model, and then gives the prediction and the outcome. This is all machine learning. So machine learning enables a machine to automatically learn from the data and improve performance from experience and predict things without being explicitly programmed. So here the machine we fed the data we fed the machine automatically learns from that data, and it improves the performance using different algorithm we train on, and predict the outcome we wanted with a better accuracy. So moving forward, we have features of machine learning. So I'm just giving you a gist of what is machine learning, and then we will proceed with the roadmap and how you can prepare and learn machine learning. So what are the features of machine learning? So machine learning uses data to detect various patterns in a given data set. It can learn from the past data and improve automatically, like I said before you. And it is a data driven technology, and that is it is all dependent on the data. So the data we give to the machine, it will use that data and then predict the outcome. So it's all about the data. If we do not give any data to the machine, we won't be able to receive any outcome. So machine learning is much similar to data mining, as it also deals with a huge amount of data. So data mining is all about data, and similar to that, machine learning also rely on the data. So if we give a data set that is giving you better accuracy, the outcome of a model will be more or less higher than a previous model. And if the data fed is like not that much that machine can learn, it will not give us the better accuracy. So we can train machine learning algorithms by providing them a huge amount of data, like I said, and let them explore the data, construct the models, and predict the required outcome automatically. The performance of the machine learning algorithm depend on the amount of data, and it can be determined by the cost function. Cost function is like the loss function. The loss, the actual outcome we received and the predicted outcome, the cost function basically adjusts itself like that. The importance of machine learning can be easily understood by its use cases. Currently, machine learning is used in self-driving cars, cyber fraud detection, face recognition, and friend suggestion by Facebook. So these are some of the example of machine learning. There are many use cases of machine learning in a day-to-day life, but I mentioned some that is in general, and you can easily recognize that here a machine learning is being used. So various top companies such as you might be knowing Netflix and Amazon's are using machine learning algorithms, and that are using a vast amount of data to analyze the user interest and recommend product accordingly. So these days you might be knowing about chat gpt, I guess. So chat gpt is also all about AI and machine learning. So at the back end of the chat gpt, all the machine learning and AI has been trained, and all the data has been fed what the user want, and accordingly what chat gpt does is it gives the user the output that is at the best and accurate. So ChatGPT works at the backend. ChatGPT is working on AI and machine learning part only. So we have some of the application of machine learning, like image recognition, speech recognition, traffic prediction, product recommendation, self-driving car, as I mentioned earlier, also email spam and malware filtering, virtual personal assistant, online fraud detection. These are some of the application of machine learning. You can go through these slides. Now, coming on the most awaited part, that is what is the roadmap of machine learning. How can we learn machine learning as a beginner? So the first and the foremost thing you need to begin with machine learning, you have to have one programming language in at your hand, like any of the programming language with either a Python or an R. So I recommend you basically Python, but you can go with any of the programming language. R is basically more inclined towards analytics and statistical part. So uh, if you have a mindset of becoming data analyst, so you have to have R. But for machine learning, I recommend Python, because I also started with Python, and it's almost the same, but like the syntax is only different. So you can start with the Python. It is easy to implement and learn, and you can find all the resources on internet on Python also. So I recommend Python or R, any of the language, but more inclined towards Python. Now the second part of the machine learning process is, now you have learned the one programming language, you need to have hands-on command on analysis part. So like you got the data set, and now what you can do, you can analyze the data, what the data is saying. You have to go inside the data and think all the possibility of what data is saying to you. You have to like brush up the data and analyze each and every aspect of data with a minute details what data is saying. So explore the data. Explorative data analysis is simply explore the data you have got. Now third step in machine learning roadmap is feature engineering. Now feature engineering includes like EDA, explorative data analysis. You have to analyze all the data. Now the data you are receiving might be containing missing values, outliers, NaN value, NaN value, null values, and data is not uh, accurate. So here you need to feature engineering the data, that is handle the missing values, handle the outlier. You need to encode like the data is of say regression. So you cannot classify the data into category. You need to encode it into numerical value. So categorical encoding is also needed. Now the spread of data is also large in some cases, you need to standardize and normalize the data in within some common range. So feature engineering is the most important part of machine learning, and this is the foremost part you need to do before model
The
development.
voice is
So
lagging.
uh, hello.
Is the voice is lagging?
No.
uh, Okay, cool. Let me start. So, feature engineering, you need to have it before building a model. So, feature engineering is must, and feature engineering includes handling missing values, handling outliers, categorical encoding, and normalization and standardization. So, whenever you have a data set that is largely segregated, and you need to limit the data within some range, you basically use standardization and normalization technique. Now, moving forward, we do have feature selection also. There are some features that we do not want in our data set, and that is uh, not that correlated and not much importance with our targeted value. So we select the important features that is depending on the target, and that might affect our target output. So we do select some features that is most important, and we do segregate the features that is not of much importance in our data. So here we perform feature selection. In feature selection, we perform five, six major techniques like correlation, forward elimination. In forward elimination, what we do, whatever we have the data and the next data, we correlate with them and find the best appropriate data point with the forward data we have in our data set. Like similar, we have backward elimination, univariate selection, random forest importance, and decision tree. So in feature selection, we do use these six techniques as major before proceeding with the model development. Now comes a part of machine learning algorithm. Now in machine learning algorithm, what we do, we basically perform a regression, classification, and clustering. So this is the main part after performing feature engineering and feature selection. So after you have applied all the, like you have learned the Python, you have got the data set, you performed EDA, you done with the feature engineering, feature selection. Now comes the part of your model building. So based on the data set, you either perform regression or classification or clustering. So we have algorithms like linear regression, logistic regression, decision tree, random forest, XGBoost, K-means, KNN, DBScan, and all these machine learning algorithms. We do train these algorithm based on the data set, and after that we received an accuracy and a model prediction. So based on the model prediction, you based on the model prediction, you deploy a model on some cloud flip framework. So this is the most important part of applying algorithms. So based on the data set, you decide which algorithm you need to put on the data set, and based on that, like the problem is about one features of independent and dependent, and it is about regression problem. Like we need to find the marks of student based on his past performance. So this is all about regression problem. So here the you have continuous variables, and independent feature is your marks and dependent feature will be your result. So based on that, you apply linear regression. So linear regression works well on continuous data set that includes one features based on the past performance. So you can apply linear regression in that. Logistic regression is more inclined for probability distribution. Like you need to find like spam classification. So whether the email is spam or not, so it's a probability distribution which ranges between 0 to 1, and linear regression ranges from less than 0 also and greater than 0 also. Like decision tree is all about uh, deciding the factors, and similar to all, we learn all these in our ML class, which we are having next with my roadmap. Now, after applying the model, you do have hyperparameter tuning. You will find the best parameter that a model and algorithm suits. So hyperparameter tuning is all about find you apply the model, but on top of your model, you try to increase the accuracy by applying hyperparameter tuning with some variables in the hyperparameter that will increase your model accuracy. Like we apply grid search, randomized search, hyperopt, optuna, genetics algorithm that basically tune our model, and it helps in model accuracy in increasing our model accuracy. Now comes a part of model deployment. Now, what is model deployment? So basically, you have made a machine learning algorithm. Till now, you have made the machine learning algorithm. You applied the machine learning algorithm and predicted the accuracy. Now, what will we do with the accuracy? So there is no such use of gaining the accuracy, and you are sitting like that. So the project you made with the accuracy, you need to deploy that project in some cloud platform so that other user can also use your project in a public domain. So model deployment is like you deploy a model on cloud so that other public can also use your project and use, and it is about public domain. So you publicize your project. So you can deploy your model on cloud like Azure, GCP, Heroku, and any other cloud platform you want with the help of Docker and Kubernetes or Streamlets. So to host your machine learning model with a powerful backend, you need to learn framework like Django and Flask. So these Django and Flask are web framework which you need to have it. Yeah, one thing more, you need to learn one web framework also, any of the framework like Flask or Django. So I learned initially Flask and Django afterwards Flask, but you can learn any of the framework. These that doesn't matter, but at least you need to know one web framework for deployment of the model. So yeah, you need to learn like Flask or Django, anyone, and then you need to have a good amount of knowledge for Kubernetes and Docker for model deployment pipeline. Now, as I said, you need to have understanding of cloud deployment. I recommend you to have understanding of Azure and AWS must, and Heroku is not that difficult, so you can have that. So any two of the cloud platform you have to understand. Now comes a part of you have got the accuracy. You deploy the model on some cloud platform. So this is the end-to-end machine learning project. So end-to-end machine learning project is nothing but the model you made, you deploy it on some cloud platform using Docker and Kubernetes or any of the MLOps. You can also do MLOps pipeline, and at the spot you deploy it on the cloud, and the public is using your model. This is end-to-end machine learning project from gathering the data, from getting the data till you deploy it on some cloud platform. This is end-to-end machine learning project. So uh, machine learning is not just learning algorithms and regression in model building, but you have to build a project such that you deploy it on some cloud platform and user is using on a public platform like Heroku, Google, GCP, or Azure, any of the cloud platform. So you have to make at least if you are beginner, you have to make at least 7 to 8 beginner machine learning projects. I am mentioning some of the beginner machine learning projects that you should start working on, and these will basically improve your machine learning clarification and how model is working. So everyone, any of you might who have started with machine learning might have gone through this iris flower classification dataset, and this is the first project any of your mentor will teach you, because this is the basic project, and this builds your machine learning uh, overflow. So iris flower classification is the first machine learning project as a beginner I recommend. Then second, stock price predictor, predicting the wine quality. MNIST data, handwritten digit classification, is used in both machine learning and in deep learning. And If I am not wrong, you will be taught MNIST handwritten digit classification projects in this machine learning cohort also. Movie recommendation system, you might have heard, and Boston House pricing prediction. These are some of the basic machine learning project I've mentioned, and you can go through with this also or any of the project you want. But start with the basics so that you get the basic idea of the project, and then you start building advanced level. So this is the overview of what I have taught you. So data collection is the first and the foremost thing you need to have. So once you collect the data, this is no, if you are going into a domain of machine learning, it's not totally your responsibility to collect the data. You will be receiving data from some other sources, from some of the other team also. You will be receiving data, so it's not about your headache that you collect the data, but you need to know that data collection is being done. So data collection is done, what data exists, what kind of data is there. After the data collection, you prepare the data. You, like I said, you will be performing feature selection, feature engineering. So it comes in data preparation, exploratory data analysis, data pre-processing, data splitting. These all comes in data preparation domain. Now, after you prepare the data, it's time to train a model. Training a model, before training, you have to choose, uh, see the data set, what the data is all about, whether it is about classifying the data or about the regression. Accordingly, you choose an algorithm based on the data you have been provided. Then you have to tune your hyperparameters for increasing the accuracy. After you have trained your model, you have to analyze your model on confusion matrix. Like you can count the F1 score, precision, recall. These all parameters you need to calculate to figure out the accuracy of the model. uh, Now, after analysis of your model, you serve your model, put your model into production, that is cloud deployment. So you need to deploy a model on any of the cloud platform. Then, after deploying your model, if your model is not performing well, then you retrain from the cloud platform and this cycle continues. So your old prediction might change on retraining the model. So with a better accuracy. So this is the life cycle of machine learning project, and it's a continuous project until you stop retraining your model. So now here comes for some frameworks of machine learning. So you need to know, before starting with machine learning, what are the frameworks you need to know. So you need to know NumPy, Matplotlib, SciPy, Seaborn, Pandas, Dask, PyTorch, TensorFlow. These are the frameworks I mentioned, and you need to know if with you need to know for starting with machine learning. So NumPy is basically used for numerical and statistical purpose. Matplotlib is more or less used for data visualization, and similarly, Pandas for arrays and Flask is for web development frameworks, and Django similar. TensorFlow mainly used in deep learning and computer vision and NLP domain. So for text classification, if you are planning for if you're going with the data set of that include text classification, you have to have basic knowledge of NLP also. So right now we are talking of machine learning, so I'm focusing more on machine learning part. So you need to have web frameworks for ML. These framework you have to have basic understanding, but for NumPy, Matplotlib, and visualization tool, you have to have like hands-on practice on that framework. Now, there are some web frameworks also for machine learning development and deployment. So, like I said, Flask and Django, you can choose any of these, and here are some more mentioned like Web2Py, Turbo Green, and CherryPy. These are extra one. If you have interest, you can go, but Flask and Django is must. Now, it's like over of machine learning part, and I've covered all the process that is being included in machine learning roadmap, from the start of data collection, feature engineering, EDA, feature selection, training the model, model deployment, and the end-to-end machine learning project life cycle. So I've covered all the roadmap, all the part necessary for machine learning roadmap. Next, I move on with the resources of machine learning. So the best book I recommend for machine learning is Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. This is the best book I have ever gone through. You can have hard copy of the this book, but you can have a soft copy easily available online. And the second course I recommend is Machine Learning Crash Course. It's a Google developer course. It's a Google course. It's a free of cost course, and you have the best mentor here, and you can have all the machine learning understanding in this crash course. Literally, I have gone through this crash course, and my concept just got cleared in some time only. So this is the best I can say. So resources, I share this PPT also, and some of the machine learning books I have with a cheat sheet and code. I'll share in the Discord, and rest these two are the best resources I recommend as of now. The next part is like machine learning resources only. So you can have, this is the book I was saying, hands-on machine learning with TensorFlow and Scikit-learn, and these are the framework you need to know. For deep learning, I'm not suggesting because you are beginner in machine learning if you are starting with machine learning. So let's finish first machine learning, and then if you are capable enough of building some good machine learning projects, then start with the deep learning part. It's not that too much difficult. uh, so it's all done from my part. You can open your mic and unmute yourself and ask any of the question you want.
Yeah, thank you, sir. That was a very detailed and informative session. I believe our audience would like to clarify some queries that they might have. So let's move on to the Q&A session.
Yes, sure. So people having any doubt, you may ask. So as I see in the comment section, from where do you get ebooks of this book? Uh, I'll share in the Discord this hands-on machine learning with scikit-learn TensorFlow. I'll share the PDF format of this book.
So currently I am doing that EDA part. I've learned
Okay.
Python in what you can say in intermediate level. So one of my
Okay.
teachers said me to that in EDA part I need to learn about exploiting data in SQL and Excel, MS Excel. So do I need to do that?
Yes, you need to do that. So for so if you are aiming for data science domain as a career, so you need to have a SQL must in your learning path. So SQL or no SQL. So I'd suggest SQL and no SQL. But if you want as a start, so you can learn with SQL. So EDA with not EDA, I'll recommend you to have separate learning for SQL, because in machine learning in advanced level you will be getting the problems of SQL. So you have to have understanding of SQL. Yes.
Okay, thank you.
So any other doubt?
Sir, I guess that's all for queries. Yeah, we are very grateful to you, sir, for guiding us through upcoming technology with your in-depth knowledge, seasoned experience.
Yeah.
We would also like to thank the audience today for the undulating curiosity with regards to the subject and the continuous support and cooperation. We hope you enjoy your time with us and gained immense knowledge and expertise as well. We thank you once again. Bye.
Thank you for having me.
Yeah, sir.
Thank you. Bye bye.